Okay, in this problem, I'm going to look at problem number 19 from the final exam review. All right, this problem could be thought of as a problem from section 5.1 to 5.4, or you could do it using some information from sections, I think it was 7.1 and 7.2. You could do the problem using like law of sines and cosines, or you could use the 5.1 to 5.4 material. So I think most of us would probably use the 5.1 to 5.4 idea. I think that's what would come to mind. The reason I'm doing this one is it can be a challenge to figure out how to get the angles that you need in order to get this problem worked out. So we need this angle right here. Well, let me explain the problem first off. So it says that you got this blimp that's 1,900 meters high in the air, and the angle of depression from the blimp to one stadium is 24, actually, I can't read my own writing, is 24.4 degrees. And the angle of depression to the other stadium from the blimp is 65.1. And then they want to know what you're trying to find is this right here, the distance between the two stadiums. Okay. So what we're going to wind up doing is working on maybe finding this length and then maybe finding this whole length and then just subtracting those two to get x. If you do that, you can make use of the two right triangles, the little right triangle to find that shorter piece, and then the whole entire right triangle. Okay. Now, if you choose to go like the law of sine, law of cosine route, you could find out what x is if you could get the length of a side within that triangle, like either this big, the hypotenuse of the large triangle, okay, or maybe this side right here. So if you wanted to go another route, you could, and it could be correct. But the thing that first came to mind for me was to try to resolve what some of these angles are, because I know that this piece right here, the red, where I put the red dot, would just be 90 minus 65.1. So this angle is 24.9 degrees right here, okay? That angle is 24.9. Now, once I have one angle in that triangle, there's a lot of other angles that I can figure out, because 90 minus that tells me this angle down here is 65.1 degrees. I also know that if I knew more geometry, if you're up on your geometry, you have alternate interior angles is another way to get that. All right, and then I really could go, if I wanted to, go from there and figure out this angle, okay, and figure out this angle up here on this piece right here if I wanted to, okay? So sometimes I just go ahead and do what I think we may not need it all. So let me go ahead and subtract 65.1 from 180. That tells me right here I'm going to have 114.9 degrees, okay? And then I could work on figuring out, let's see, probably the next thing that I might get. I actually know this is 24.4 because of alternate interior angles. So I know this has to be 24.4 degrees. If you didn't notice that, you could figure it out, because you can find just this angle by taking 65.1 and subtracting the 24.4. See how this is 24, this is 65.1. So just this angle has to be 40.7. And then you could take the 40.7, the 114.9, see what that turns out to be. And when you subtract that from 180, you'd see the 24.4. So there's different ways of getting where you need to be, and you don't necessarily need all of those angles, but sometimes, you're not sure what to do, where to get started. So it helps just to have some options. All right, what I'm really noticing though, is that I'm going to do it in blue, the pieces I'm going to use. I could use this angle, this side, and then I could find this missing piece, this little piece right here, which I'm going to call A. Okay, so I could find that because the relationship between A and the 1900 and the 24.9 would be tangent. So I could do the tangent of 24.9 would equal degrees, would equal little a over 1900. And that would tell me little a. Okay. Well, I could actually kind of use a similar setup if I wanted. I have one more angle I need to find, believe it or not. So if I found, let me do the angle in blue, I could do a similar setup. If I could figure out what the angle was, trying to decide where the best place, let me do it in bright green, all the way from there to there, to find that whole angle. And I can do that. I just need to add the 40.7 and the 24.9. So the 40.7 I found here and the 24.9 make up that angle, which is in the larger right triangle. Okay. And it turns out to be 65.6. So this angle right here is 65.6 degrees. And so, it's kind of a similar setup if I think of it this way. Then the tangent of the 65.6, that angle up at the top on that large right triangle, would equal this whole length, which I'm going to call B, divided by the 1900. So it's kind of a similar setup. And then when I'm finished, I can just subtract. All right, so let's finish both of those out. So little a would just equal 1900 times the tangent of 24.9 degrees, and B would equal 1900 tangent 65.6 degrees. So once I type in 1900 tangent of one of them, make sure you're in degrees. I was. Okay. That one turns out to be about 881.95. Then I'm going to just go back to what I already typed in and put 65.6 right over the top of the other one. And that gives me 4,188.53. And I'm carrying a little bit of accuracy here because I forgot to read. They wanted it, how far apart are the stadiums to the nearest meter? Okay, so B, which was the whole entire thing, so all the way from there to there was B. Okay, that turned out to be 4,188.53. I'm going to subtract from that this little piece right here. So B, let me do it in green. B was that whole thing, and then A was just this little piece right here. Okay, so if I subtract the 881.95, that'll give it to me. So I'm going to take my 4,188.53 minus my 881.95. I like to keep a little more accuracy on things until I get near the end. That gives me 3,306.58, and it said round to the nearest meter. So if I round to the nearest meter, this would be 3307. Okay, and that would be 3,307 meters apart. Okay. All right, and I'm going to just do that one in a video.